Hello, good evening all. All right, so today we are going to continue our Form 5 Chapter 1. And for those who just know my channel, my physics tuition will be free on February. Free on February, yeah? And March, no more free, yeah? And then the promotion, we got a promotion, which is if you join before February, right, the end of the February, you will enjoy the whole year monthly tuition 49 ringgit and 90 cents. But after February, there will be no more this promotion. If your friend need a tuition, right, ask them to join before March, before end of the February, right? All right, so before we start, we slightly look at what we have done last week. The thing that we had done last week is we got a resultant force. All right, resultant force. What is resultant force? All right, if we got a force here pulling with 15 newton, here 10 newton, so we got a resultant force of 5 newton. So this resultant force will cause a acceleration of the object, right? Whereas F is equal to ma. F is equal to ma, right? This is Newton's second law. And then if the object it is not we don't have the don't have the resultant force, then we gonna have a balance force, right? Or we call this as equilibrium, right? This one is equilibrium. So this object will be either not moving or it will move with constant velocity, where the acceleration here will be 0, right? This is what we learned last week. If you see here, right? If you see here, the force is greater, right? Greater, then it will accelerate to this side, right? If this force is greater, it will accelerate accelerate to the right hand side. This is what we learned last week, and last week we have done some quiz. And then we got a few situation 1, 2, 3, and 4. I said fourth today, next week, this week lah, we are going to do it. Right? This week we are going to do the fourth situation 4, which is not perpendicular, and then it is not left and right only. Right? It involves more direction, right? Any other direction. So we are going to focus into this one. If this one we can finish, then we go to 1.2. All right, so today maybe we cannot do any quiz. Why? Because of we cannot finish chapter 1.1. Then if I do it halfway, then you cannot do it, right? Quiz. All right, this is what we have done last week. All right, basically every time before the class start, I will also revise back what we have done last week, right? But just briefly, right? So how to do it, this one, all right? For example, this is the one that we had done last week. So we know that F is equal to ma. So we got a resultant force 15 minus 10, right? 15 minus 10 is equal to ma. M it is mass. Mass it is 2 here, and then acceleration I don't know. So we can calculate the acceleration. Phi is equal to 2a. So a gonna be 5 divided by 2, which is 2.5. The unit of acceleration is ms minus 2, right? This is what we learned last week, right? Of course, if last week we have done some, which is if it is not in smooth surface, right? This is what we've done. It is smooth surface. What if it is not in smooth surface, right? If not in smooth surface mean if the object I pull here with 10 newton, and then this is not a smooth surface, this is rough surface, they will give you a friction. right? Friction, normally I will use this symbol, right? Let's say 2 Newton, all right? This is 5 kg, the one, 2 kg, 2 kg. So 10 minus 2. The friction always against you, against your movement, right? If your object is pulling to this side, then the frictional force will be into this side. If same thing, if your object it is pulling to this side, right, 10 Newton, then you're gonna have a frictional force of this side, right? Always against your motion, right? Okay, always against your motion. Right, I hope you're okay with this. Now, this one is the one that we had done last week, all right? So we are going to start from here, all right? The direction, which is not perpendicular, and then not left and right only, and then we don't take any frictional force into this system, right? We are going to do this kind of question, and the answer here, it is wrong. Anyhow, we still can do it. Okay, so let's start our lesson today. So now here, that is a 5 kg object, right? So it is being pulled by two direction. One, it is this 15 Newton, and then the other one will be this direction, 10 Newton, all right? And then where will it go? So it will go some in between these direction. So I need to draw. In SPM, this kind of question, very hard to come up. Not to say cannot come up, very hard to come up. Why? Why very hard to come up? Because there is not enough mark for this calculation. If they ask you, they must ask you how to drawing. So drawing normally 2 marks, so it will not be so complicated. So that's why I give 2 example only, right? If these 2 examples finish, you are okay, then we go to other part. All right, so now we are, firstly, what we are going to do is we need to draw by using drawing to get this answer. So this 15 Newton, normally you are going to take this 15 Newton as 15 cm. But anyhow, you can use scale drawing, right? So you divide it by let's say by 2, all right? You got 7.5 Newton, all right? And then here, you need to draw another one, all right? This is the force, all right? So you need to follow this direction, which is 10 Newton. Here it is 15 Newton. And then here it is 10 Newton. So you got this direction. Red color. Okay. And this is, we called it as rhombus, right? Right? Rhombus. Oh, okay. Now this one, you can take it as, right? As I told you, if you want to use scale drawing, you can put it as 7.5 cm. You can put it as 7.5 cm here. And then this one, you take it as 5 cm. You divide it by 2. All right, how do you get it? All right, so this one you divide it by 2. This one you divide it by 2. So here it is 5 cm. And then here will be 7.5 cm. And the direction you must know. You must know very well for the direction. Okay. So you must know the direction. So this one, the direction will be into this way, right? The direction in the drawing, scale drawing, you have to draw it. In the exam, you have to draw it. But I will say, not really have chance to come up, right? This direction and this direction. All right, you see, this 5 cm represent the 10. This 7.5 cm represent the 15. All right, 15. And this one is your resultant force direction. Right? Resultant force direction, we normally draw with 2 arrows here. Right? We normally draw with 2 arrows. Okay, so now the scale is divided by 2. Alright, so this is your resultant force. Resultant force, we are going to label it with FR, resultant force. Right, this is our resultant force. After draw it already, now you need to know here. This one is your angle of 30 degree. So where is the 30 degree? This 30 degree here, it is in between 15 to 10. It is in between 50 to 10, meaning that a lot of students they get wrong between here is they thought this one will be 30. No, this is not 30 degree. No, right? Whereas this whole thing it is 30. Whereas in between 5, which is 10 Newton and 15 Newton in between these two. Now, teacher, why do you take it as 5 and 7.5? If you draw with 15 cm, your ruler will be not enough. Too long, right? Too long for your ruler to do it. So normally when you draw 7.5 cm. All right. If you divide it by 3, can or not? Cikgu, this one divided by 3, okay or not? Yes. But this one, you need to do 3.33. 3.333333. 10 divided by 3 is 3.3333. So hard to get it, right? So no, normally we divide it by you got a round figure, all right, or 0.5. It is easier for you to draw, right? So and here we need to draw here one more thing is here it is 30. We need to know this one it is 30. This angle it is 30 degree, right? So after we know it already, so you know this angle will be equal to this angle, right? So because of I'm not drawing right now. When I am not drawing, then this angle I want to use calculation. So you have learned sine rule and you have learned cos rule in your maths. So you need to know how to calculate this one, right? So in your exam, physics, just drawing. But this one, I am going to do calculation for you. So this one is 150, which is you got it by 180 minus 30. So you got 150. So now I want to do the calculation right now. All right. So FR, do you see a triangle here? Wait. Do you see a big triangle here? Sorry. Here. Do you see this triangle, big triangle here? This triangle. So I'm going to take this triangle to calculate, right? This triangle. So this triangle is, you use cos rule. You use cos rule to calculate. Cos rule said that a square is equal to b square plus c square minus 2ab cos a, bc cos a, right? Whereas the FR square, FR resultant force square, right? Square is equivalent to opposite square is equal to side square. Side square plus side square. Side square. 7.5 square plus 5 square minus 2 times 7.5 times 5 cos 150. Cos 150. So by pressing calculator, you can get FR. Alright, so I am going to press the calculator right now. I'm going to press the calculator right now. Whereas opposites, this is 7.5 square. 7.5 square plus 5 square minus 2 times 7.5 times 5 times cos 150. Alright, so we get FR square. This is F resultant force square. Resultant force square, and then I need to square root my answer. Right? Square root is my FR. So my FR is 12.09. Right? FR will be equal to equivalent to 12.09. Right? 12.09. 12.09. And then this is not Newton, this is in cm. Because I said you are using drawing, right? When you are using drawing, this is not in Newton. So remember just now, how to get this 5? We divide it by 2. How to get this 15? We divide it by 2. So your FR will be, you need to time it 2 back. Alright, 12.1 cm. In your drawing, you cannot get 12.09. So drawing, don't tell me, hey, Cikgu, I can get 12.09. So no, you can get 2.1 cm. 2.1 cm. Alright, you get 2.1 cm. So when you get 2.1 cm, your resultant force will be 12.1 times 2. Right? So 12.1 times 2, you get 24.2 Newton. So whereas the answer here I gave you, it is wrong. This answer here will be wrong. Help me to do correction here. Yeah, this one I do it wrongly. I do it at another class, right? I know it is wrong already. Right, this answer, help me. This is wrong. This answer, the correct answer will be 12.2. Is that okay for you? Are you okay with this question? If you have no question, then A, we have done A already. Find the resultant force. Now, the magnitude already, so we need to do where is the direction, right? So B normally, we are going to find the direction always at the angle of above this angle, right? This angle, above the horizontal fx, that horizontal angle. So what is the angle that we are going to take is, now we are going to use sine rule. All right, so I am going to label this one as theta right now. Ugly. This is theta. So sine this one, sine theta over opposite is sine 150 over opposite. So I can use sine rule. All right. So I am going to use sine rule. Okay, how to use sine rule here? Right. Sine theta. I'm lazy to use this. Okay. So sine theta is sine theta over, where is theta? I need to find sine theta over the sine, what is the angle already? Sine theta over, oh, not over sine, over 5. Opposite is 5. Opposite is 5. Right? Is equivalent to equal. Right? Sine opposite is sine 150. 150 over the opposite, which is just now the angle will be, this angle will be 12.1. 12.1. This length, not angle, 12.1. Okay, this is what we have. I repeat one more time for you. I thought you don't understand. Sine rule, I forgot to write sine rule. Okay, I'll write it later. Sine this angle over opposite is sine this angle over opposite, right? Because of this one, I use 5. This one I need to use 12.1. If this one I use 10, then I need to use 12.4 here, right? So you follow the diagram of the triangle will be okay. All right, this is what we have, right? This is sine rule. Okay, sine rule. So we are using sine rule. So what's the answer? All right, if you find this one 5, you time it up, it is sine 150. sine 150, sine 150 divided by 12.1 divided by 5, right? Sorry, times 5. I'm sorry, times 5. Times 5. Times 5, huh? So you got 0.2, and then that one is your equal to your sine theta. So I need to shift sine answer equal. Sorry, one more time. Sine 150 divided by 12.1 times 5 equal. Shift sine answer equal. You get 11.93. Right? Theta will be equivalent to 11.93. Theta will be equivalent to 11.93 degree. Okay, so theta will be equivalent to this answer, right? So this answer here is this correct? Right, this answer also wrong. All right, is that okay for you? The C, the answer there will be wrong later. You are going to check. Now, any question from here before I continue? Any question before I continue? Right, if no, then we are going to see the next one. Right, C. How are we going to do it? So we need to find the acceleration. So as I told you just now, here, this, it is not to a surface. So you don't have what, teacher, what is a frictional force? No. Now, of course, you ask me, Jegu, if no frictional force, no what, then how is this thing is going to work? Right? How? So you don't think of that way. Right? Because of this one, it might be in other situation that you cannot imagine. Later, I tell you one situation that you can imagine it. Okay. Later, I tell you how to make it logic here. So when you want to calculate the acceleration, you need to have F is equal to ma. Whereas this one is your resultant force. What is the magnitude of the resultant force? 24.2. So you got 24.2. Is equal to ma. Your mass, it is 5 kg. And then A don't know. Right? You need to find the A. Right? You need to find the A. So it is 24.2 divided by 5. You get it as 4.84. 4.84 ms negative 2. Is that okay for you? So this answer also wrong here. Okay. What is the answer here? It's supposed to be 4.84. Are you okay? Now, of course, you ask me, teacher, how to make it logic, right? Okay, now, let's say, teacher, no friction. How can it work? No friction, or I don't understand. So this is our Earth, right? So let's say there is a satellite here. Now you have to imagine that you are an astronaut. Astronaut, you know what is astronaut, right? Do you? You know what is astronaut, right? Astronaut, right? 宇航员, astronaut, right? Angkasawan, right? So you are Angkasawan, and then this is a satellite. This satellite just 5 kg, right? So you are at here. Now, calling from the Earth, right? From the station, right? Tell you, they send you a signal. Any satellite, not good position, not tune, not right position. So to make it right position, you got two astronauts have to push it. Right? So one of them push with 10 Newton. No friction. Because this one no air, no nothing, no friction at all. And then this guy, Right, this guy had to push it with this guy want to push it with another force here, which is stronger, 15 Newton, right? 15 Newton. So after you have pushed it, then this satellite will come into this direction, right? And then after you push it, it has one acceleration. How much it is? Oh, 4.84. If you do this way, right? So here look like not logic, this one got ground, but actually I said this one will be in other situation. Probably it is in outer space. No frictional force. If you got frictional force, the question will tell you what is the frictional force. Then you have to deduct the frictional force. Now, any question from here before I continue? Any question before I continue? Any question? All right. If you are okay, then we are going to move to the next one. And before I forgot, the direction here we are going to learn in detail in resolution of force. Right? You will see this direction. If you draw it in triangle, the force, you see this force you pull to here, 15 Newton. Here, 15 Newton. And then you got another force, which is pushing in this force, all right? Which is 10 Newton, right? So your direction of the force, because of this one is resultant force, right? I told you this triangle, the small triangle. So this one will be a 24. We have calculated 24.2 Newton. You see the direction here. The difference is this direction, it is not going to come back. Right? Your direction is you go from here and then go to here, mean your object is going to move into this direction. Mean this one is not in equilibrium. If it is in equilibrium, it will be into this direction and then come into this direction and come back. Equilibrium, it will come back. Right? So this one is not equilibrium, mean it will accelerate. Any question from here? No, right? Other got question? Got question, please ask. If no, and this one not really come out. In the school, small test, yes. In SPM, susah not come out. So that's why I don't give so many example here. Just to cukup makan. Right? Okay. Now, okay. Now before I continue, alright. So let's say that is an object here, 2 kg, and then you pull with this direction 10 Newton, I pull with this direction 15 Newton. Where do you think it will go? Right? So before here, I ask you, see whether you understand or not. 10 Newton here. Alright. This one is 150 degree. 150 degree. So A, it will come. Alright, I use other color. Alright. A, it will come into this direction. B, it will come into this direction. C, it will come into this direction. C, no. I will say C, it will come into this direction. Or D, it will come into this direction. So answer will be A, B, C, D. Which direction it will go? Which direction it will go? A, B, or C, or D? What do you think? Which direction it will go? A, B, or C, or D? In which direction it will go? Who votes only? How about others? How about others? I just did one video before, alright? I don't know whether you watch it or not. Right? But never mind, I show you. I show you my video that I did it for last week for your understanding. I don't know whether you watch it or not. Wait, I'll show you. Okay. So see here. Okay. So let's say I got a force, right, pulling into this direction. I got a force pulling into this direction. And then I got a force pulling into this direction also. Where will it go? Logically. So you come into this direction, right? This is your resultant force, am I right? So if I got a force pulling into this direction and this direction, so we got a resultant force. Am I right? You double see? You see it again, whether you understand or not. So that is the direction of resultant force. Am I right? Okay. All right. So if you got one force pulling at here, all right, this one, you got one force pulling at here. You got one force pulling at here, then logically it will move in between because you got a force here, you move in between, right? Resultant force. Now you got a force pulling here, you tarik the tali, you tarik the tali, you tarik here, you pull. Where will it go? Where will it go? Where will it go? You can see, right? Where will it go, right? So, wow, macam-macam answer ada. Right? 4 votes only. How about other? Help me to vote it before. I really want to make you understand whether you really understand or not. How about other? Help me to vote. Answer? Answer. So I lazy to do it right now. If I want to do it, I mean I need to use, I can do it lah, but it's spending me time. Never mind. To make you understand, I'm willing to do it. Wow, ABC semua ada. Right. Okay. Seems like you guys not really understand. That I need to show you. How? Wait. Here's my calculator. We do it together. This is my table. And I text all that first. This is my calculator. 1 minute lah. Okay, I take some sellotape with tali with thread, and then I need to move it into 2 direction. So this is 我的牙线 my teeth thread. Okay. Okay, I pull one to this direction, so I'm going to stick it into here. I'm going to pull into this direction later. And then one more, I am going to pull into this direction one more. Okay, I am going to pull into this direction. I'm going to pull into this direction. One is pulling this direction. Right? You see the question. Let's look at the question first. Right. One is this direction. Up. Up. This way. The other one is going to the right. This way. Right? So I'm going to pull it right now. You see? Where will it go? Yeah? Here? I pull here. I pull here. Where will it go? Forget about the pull. Alright, forget about the pull. And then now you answer me. A, B, C, D. Answer me if you see the experiment that I've done. Right? Where will it go? A, B, C, D. One more time. One more time. Okay? This one after I pull, it will go A, B, C, or D. A, B, or C, or D. One more time. Answer in the chat box. A, B, C, or D. You see, just now got D, got A, got B, got C. Macam-macam ada. Now you tell me, right now, you see from the video. Then you tell me, where will it go? It go into which direction? D, right? Obviously, it is D, right? Now you know that one is a result of the force. Yes, good. Now you understand. Now you understand, right? So into this one, yeah, this is the result of the force. You pull here, 15 Newton. I pull here, 10 Newton. Where will it go? Both will go into this direction more. Impossible to come into this direction, right? Impossible to come into all of this direction, right? So it come into this direction. Either left it is more, and then right it is lesser, right? 10. This one is 15 or stronger. You pull stronger here. I pull weaker here. But so it will go more into this direction. Whereas this is my answer. Am I right? So answer is D. So obvious answer is D. So we know that the answer here, but I don't know. I know it's in between here, here. I don't know where. But this one is 15, so I would rather believe it will go more to the right hand side a bit. You understand what I'm saying here? Because this one is stronger. I believe it will go to the right hand side more. I got another way to calculate it, but I will make you more confused, right? So I don't want, which is using tangent one. You have to resolve into this force into 2 directions, whereas I haven't teach you what is resolution of force. I don't want. So now we are going to do this one. We are going to do this one. Now we are going to draw it 15 and 10 or same. Okay. Now we draw a triangle. Not triangle. We draw a, what's that called? Rhombus. Here 10, and then here 15, and then here 10, and then here 15, right? Okay, this is my answer, and I drew it cantik sikit. Okay. Here. do it nicely lah. Okay, okay, well, probably not June lah, but it is okay lah, right? So now it is this point 2 kg, this point is where your starting point, right? So you are going to pull with one direction here. Now I'm going to label all the forces direction. This is 10 Newton. This one should be shorter. This one will be longer because it is 15, right? This one is 10. The direction must be parallel. This one is 15, all right? So since we got all the direction, so I don't want, let's say I don't want to divide it by 2. Cikgu susah lah. All right, leave it as 10 cm. Okay, no problem. Unless the question said you must draw it with certain scale, then you follow. This is 15, right? This is 10. This is 15. Okay, so I got everything right already. So now I want to draw my direction of the resultant force. It is in this direction. Are you okay? This is your direction of the resultant force, where you start from here and then you end at here, right? You imagine that. You imagine it, right? I am pulling here, you are pulling here, then the object come into here. Or you can say, hey, you start from jalan from here, you work from here, and then you work to here, and then you are going to from here to here. You are going into this way. Also can. Right? But you break into 2 direction, you cannot lah. Use triangle boleh. See, you see here, you go to here, and then you come to here, and then this is your direction of your resultant force. Resultant force, So the resultant force, as I told you, I will normally use 2 arrow, and then I'll label it as F arrow. Resultant force, F arrow. F arrow. This is my direction of resultant force. So I want to calculate this one, how much? Right, magnetic. But before that, I know this one is 150. Right, the angle here is 150. So I'm going to put it in. This angle will be 150. Right, 150, yeah? Meaning that I don't want to spoil my drawing. So I am going to use the dotted line here. Here. Not June. Okay. So this one will be 150. Are you okay? You get it right? 150. So you know what is this angle? You know what is this angle? Right. So this angle is 150 minus 180 minus 150. It is 30 degree. Right, from calculation. Right. If in physics, you just draw. You don't need to count. Now, because of I taught you, you need to count. Right. So you use cos rule and calculate for me. Calculate the F arrow for me. F arrow, resultant force. Don't tell me cikgu 3.6.34. This answer might be wrong one. You see, I purposely do the wrong one for you. Okay. If you don't know how to use cos rule, then you have to learn. Right? You know how do I taught my student? Right? You want to use cos rule. Last time, I told you few years ago, 4 years ago, 5 years ago, a few years ago, I teach. Right? I teach at maths for more than 10 years. Right? But I start to quit teaching at maths. Not because of I cannot teach, because of I want to teach physics more. Right? So I let chance to have other people have chance to teach. Right? So see how I do it. All right, this is A, this is A, this is A, this is B, this is C. Opposite, it is B. Opposite here, it is C. C punya opposite is C. Right? So you open your hand here. Here, opposite. So opposite square. I always memorize by using this one. Opposite square. Opposite square. Opposite A punya opposite is A. A square is equals to side square. Side square is B. Side square here is C. Side square plus side square, right? B square plus C square. B square plus C square minus 2. Then side. After you square, you have to minus back, right? B and C. And cos A. Cos back, right? Cos you these two and then come back, right? Opposite square is side square plus side square minus 2 side. Come back. If you still don't get it, all right, you refer to the formula, right? You see, if you open your hand into this way, you see, you are here, all right? Opposite square, B square is equals to A square plus C square. After you plus, then you minus lah. 2A and C, 2AC. And then cos back to here. Cos middle back. Cos B. Do you get it? If you want to have C, opposite square C is equal to side square plus side square. This is opposite, right? A square plus B square minus 2AB cos C. Right? I hope you get it. I hope you can get it. Now you see your triangle is here, right? Your triangle is here. You got this one and this one. Opposite square, FR square is equal to side square plus side square minus 2 side. Cos apa? You can write it on your own. Opposite square is equal to 15 square plus, after you plus, you minus, 10 square minus 2 times side. 2 times 15 and 10 cos 30. Are you okay with this? And then press your calculator and get me the resultant force. Is it equal to 6.34? Fifteen square plus 10 square minus 2 times 15 and 10 and 150 lah. Cos 30. 65. 65 is FR square. I want FR, resultant force. Right? The square root of your answer, you get at 0.07. This answer is wrong. Right? At 0.0. You need Newton. This one boleh use Newton. Or you want to use cm will be okay. Right? If you use cm, later you will say, oh, my resultant force is time 1. Scale drawing, but do you get what I mean? If you want to use Newton, it is okay. Make sure you draw it. Any question from here? Okay. So I want to do B already. So I know this, and this is at 0.07. Oh yeah, scale drawing. Because I use calculating. If scale drawing, you cannot put at 0.07. Because your ruler, you cannot add at 0.1, at 0.07. You cannot read until there. So the reading will be at 0.1. So as I told you, if you said, because of physics is all drawing, I said many times already, physics is drawing. They will not ask you use cos rule, right? You see your textbook don't have, not teaching you cos rule. So this one FR will be 8.1 Newton. I explained to you why already. Why 8.1? Because you cannot read 8.07. Okay. Now the angle also, now we are going to measure this angle. So I want to find this angle. Help me to find this angle. Use sine rule. Use sine rule to get me this angle. Help me. Sine rule to get me this angle. This one or this one is this one or this one. Help me. Calculate for me. We use 8.1. Give me your answer. What's your answer? What is your answer? What's your answer? Give me your answer right now. $38.29. Janine. Yeah, my calculator full of check. Hey, why I got calculator there? Yeah. Right. Sine 30 divided by 8.1 times 10. Then shift sign. 1, 2. Okay, 38.12. Right. Yep. Oh, I know. Right. Maybe you get used to you press this one. No leh. This one is degree and minute. If you do in MS, it is 38 degree and 7 minute. This one is 38.12. Okay, good. Okay, 38.12 degree. Here's my degree. Okay. Now, of course, you will tell me, Cikgu, this is sine or shift sign got two angle or got first is acute angle and then the other one it is not. What is that angle called already? Acute and more than 90 is called what? You're not teaching, I forgot already the angle. Sudut cakar. What is that called? Forgot what is that called already. Sudut tirus and sudut cakar. Cakar is called I forgot. you know you learn it, you name it. And then shouldn't it be 180 minus 38.12? That one is MS. This is physics. You see this angle, you don't need to tell me what is the angle. Just tell me 38.12 enough. Right? Is that okay? Any question before I continue? Now, of course, if you really answer, it must answer in this way where I told you last week, which is the angle will be 38.12 in between 50 and 10 Newton, right? And then 38.12 away from 15 Newton. I repeat, last week I do explain to you why, right? The angle will be in between 15 Newton and 10 Newton. And then it is this angle will be 38.12 away from 15 Newton. But as I told you, right, this one physics, they will not ask you until that hard. If they really ask you so, then you tell properly, right? This answer is wrong, huh? Wait. This answer is wrong, huh? E. This answer is wrong. This answer also wrong. This answer also wrong. Right? Followed by this answer. The answer will be 8.1 Newton and 38.12 degree. Here hard for me to write degree. I don't write degree, I don't write degree, because of if I want to write degree, I need to go for that one. That equation, susah lah. Right, susah. And then C, right? Last one, C. How to do C? F is equal to MA. And F is equal to MA. F is equal to MA. F is your resultant force, 8.1. Is equal to MA. Mass is 2 kg. 2A. A will be 4.05. Is it? Double check, 8.1 divided by 2. 4.05. Okay, any questions from here? This is how the direction if situation number 4. This one, if you don't copy, it is okay. I will send it to you later. Right? So this is, as I told you, situation number 1 already, situation number 2 already, situation number 3 already. This is not perpendicular, not this one, right? Not perpendicular, not left, right only. So it is other angle. This other angle we use sine, you use cos to find. Normally you use cos rule to find the magnitude. This is a fourth situation. Now, I guess you are okay, right? This one is 4.05 ms negative 2. So can I move on? I have finished part 1 already, which is 1.1, the resultant force. All right. Okay. So I want to move to the second part now. Right now it is resolution of force. Right. And before we learn resolution of force, right, next week we are going to go in detail. This week we are going to learn what is the type of the force that we have. All right. We are going to see the first one. But before we start to learn what is the kind of force, what is the name, so we need to know what is the law. All right. So this is come from origin for Newton third law. Newton third law said for every action, there will be a reaction. Same magnitude, but opposite direction. For every action, there will be a same magnitude of reaction, but just opposite direction. What does that mean? Right? Remember, this one you have learned in Form 4. Form 4, you said, this is a ball, alright, this is a boy, and go and kick the ball, right? Kick the ball. I don't know how to draw kick. Kick the ball. You're going to kick the ball. So when you kick the ball, you got one impulse. So this one is called action. And then action will give you one reaction. One action will give you reaction. So if there is action, then there will be a reaction, just opposite direction. So what does that mean? If you kick the ball with 10 Newton, all right, the ball will feel 10 Newton pain. Oh, you suck it, the ball set, right? And then your leg also feel pain. You also feel, your leg also feel pain. How many Newton you receive? 10 Newton. If I slap you with 10 Newton, I tampa your face with 10 Newton, your face sakit? Yes, 10 Newton. But my hand also sakit, 10 Newton. Same, the force will be same. So every action there will be a reaction, right? But just opposite direction. Meaning that, let's say I take one more example, that is a trolley. That is a trolley moving, all right? I'm not moving, let's say not moving. Not moving, all right? If you don't believe, I can calculate for you. We coba calculate. We do revision a bit lah. The first 2 chapter no need so serious lah. Okay, go slow a bit. Okay, so 5 kg, 2 kg. This one, let's say 5 kg, cincai, right? This one, it is rest, not moving. Rest. This one is rest. Right, this one is moving with acceleration to hit this trolley. I got 2 trolley. I name it as A and B. Right, trolley A and trolley B. This one no need copy. Just understand what is. Just understand what is this then. Right. So let's say this one is moving with 10. Okay. 10 ms minus 1. Right. So after they collide, they don't stick together, let's say, right? This 5 kg, this is before collision and after collision. The size, I don't care lah. I don't draw well, alright? I know I'm not drawing well, alright? And then this is 2 kg. This is before collision. Before it hit each other, right? And then after it hit each other, you hit something. Then this one rest, it will start to move, right? Let's say it moved before. Let's say lah. The one that we know that it is principle of conservation of momentum, right? Right? Principle of conservation of momentum said that, this trolley A hit B, boop. Then this one is going to slow down. They'll ask you calculate the velocity of A. Velocity of A. So how am I going to calculate? Right? How am I going to calculate? We calculate m1u1 plus total momentum, this one times this one, m1u1 plus m2u2. This one times this one is before collision. Is equals to m1v1 plus m2v2. And then let's say the collision time is 1 second. I just take it as 1 second. Collision time, bang, 1 second. In fact, 1 second is too long already. But never mind, I just put it at 1 second. Chin chai, right? So 5 times 10 is. You just listen. You don't need to copy this one, right? 2 times 0. Right? You just listen. Just enjoy my lesson will be okay. Right? This one revision. 5 times b, 5b. 2 times 4. Alright. 50 plus 0 is equal to 5b plus 4 times 2 add. You move the add to here. Left 42. B is 40 divided by 5. 8.4. Right. We take calculator. 42 divided by 5. Is it? I takut salah, That's why. Yeah, 5. 8.4, 8.4, So this velocity is 8.4. We have calculated it as 8.4. Right. Now, from what we have learned is here we got one impulsive force, right? Impulsive force, impulse and impulsive force, it will be the same, right? Here, trolley A, yeah. What is the impulse? Right? What is the impulsive force? We calculate what is the impulsive force. Right? My question is, what is the impulsive force for trolley B? Trolley B, what is the impulsive force? So impulsive force is mv minus mu divided by t. Right? For impulsive force is B, m or 2 kg, 2 kg. V, final velocity 4, 2 times 4. Right? Minus mu, mu 2 times 0. Right? 2 times 4, minus 2 times 0. Over, right? Over t. T is 1 second. As I told you, 1 second. So how much is this? At minus 0. At minus 2 times 0. At minus 0 is at divided 1 is at Newton. Oh, at Newton. So meaning that car A, trolley A hit B, you give B at Newton. What do you think the trolley A will get? Impulse law. So this one is called Newton's third law. Newton's third law said when any action, there will be a reaction back to you. So, if this one at Newton, I believe force of the A also at Newton, but opposite direction. Opposite direction, later you will see negative. Right? Believe me? Then we calculate. We calculate. What is the force of A, trolley A? Force of trolley A is M. 5 kg. V, 8.4. Minus M, 5. U, 10. Over T, 1. Right, this one susah sikit lah. We calculate by using calculator. Okay, 5 times 8.4. 5 times 8.4 minus 5 times 10. 5 times 10 is 50. Negative 8. Why negative 8? Why negative 8? Why so true no negative 8? Oh, yalla, you got one force forward, then you got one force backward. That is called Newton's third law. Newton's third law said if I got a reaction, then I must have a one action. If I got one action, I must have reaction. But same magnitude, magnetic same, but just opposite direction. If car A hit car B, sakit. Car B said sakit, sakit at Newton. Car A will say, I also sakit there. Also at Newton. Do you get what I mean? Right, that's the concept lah. That's the concept. Right, you don't need to copy, I takut I confuse you. Okay, now see, what is this? All right, so for every action there will be a reaction, but opposite direction, same magnitude. All right, so now if I said I got one weight, all right, if I got one object, you need to memorize this, right? Need to not memorize, this one later you see this one is kacang lah. Right? Now it is you see, cikgu, why so hard one? All right, because I just explained to you something hard. Right? If I said you got one weight, then why it is not dropping? Right? Got weight. If without this, no this stable, this thing should be dropping. Why it is not dropping? Because got one force going upward. This force is called normal. Right? This force is called normal. Why it is called normal? Don't ask me why it is called normal. I know lah. I can tell you why it is called normal. Because it is 90 degree. This one is always 90 degree. That's why it is called normal. Normal is tangent punya opposite. Tangent and normal. So this is called normal. Why? Because always 90 degree. You see, always 90 degree. So it is called normal. Normal reaction. Meaning that, if I got one scale, right? Scale, timbang, you got one scale, I got something, 10 Newton put on it. 10 Newton put on it. I put one object on the scale. Yeah. Before I put this object to the scale, the reading will be 0. Right? Let's say this is 10 Newton. I said this one is 10 Newton. 10 Newton. 10 Newton. I put on it 10 Newton. Then this 10 Newton will act on the scale. So act on the scale. So this scale will give me one reading back. How much? Oh, the reading of the scale is reaction. Or 10 Newton. You see as 10 Newton. If I said this object is 10 Newton, right? The reading of the scale, it is called reaction or normal reaction. I normally call it as reaction only lah. But you can call it normal, you can call it reaction, you can call it normal reaction. Right? So 10 Newton. Okay. Now, if the object is not moving, if the object moving, other story. Now I am talking about the object that stay at rest, not moving. So the force go up, here, upward. You need to understand the upward force is equals to the downward force. 10 Newton, 10 Newton. If this downward force, it is 20, then what gonna happen? So 10, if you say the reaction is 10, this thing means cannot support, it will go down. It will break the scale. Boom. Cannot support. So now you tell me, Cikgu, this one berat, this one heavy, it is 20 Newton. So this one you see, this one is 20 Newton. That's why 20 Newton. Why it is not moving? If it is moving, mean it is not at rest, mean it is not equilibrium. Not equilibrium, we cannot do this kind of question. They'll ask you acceleration how much. Okay, so the thing that you need to memorize is when it is not moving, W is equal to R. W is equal to R. Weight is equal to W. Right? Which is R. Normal reaction is W. Right? R is normal reaction is equal to W because it is not moving. Okay? That's all. We look at the second situation, second one, which is if I got one rope, right? One tali, it is hanging on the wall, right? Hanging on the ceiling, not wall. Hanging on here. Let's say this one got one weight. 100 Newton. So this tali must have one force to support it. How much is this? Must be 100. If this one not equal to 100, meaning that this force cannot tahan 100, then the string, the tali and the thread will be putus, will snap. Putus. This one putus. Putus. Why? Because the weight too heavy, cannot tahan. Right? Like for example, you look at me. Look at me, If I ask you, here. This one. Here. Let's say this is 10 Newton. At 10 Newton, At 10 Newton. 10 Newton. So you got one force that more, it is 10 Newton here. This one is 10 Newton. What is this force called? I'll tell you later. Right? You got one force. Right? If this one now, this one cannot tahan. Putus already. Right? The weight too big. The weight too big, then cannot support. Cannot. It cannot support. Right? If too big, then putus lah. Like just now, putus lah. This one too big, cannot tahan, then putus. Right? So now if it is not moving, just now like not moving, so the weight going down, it is weight is going down, it is 100. Now this is called tension of the rod. Tension of the rod. Now I show you something that here. You see, the tension it is, weight it is 100, tension will be 100. Right? Tension of the rod will be equal to the weight if the object is not moving. Meaning that here, I show you here. Now the object is not moving. Here. The object is not moving. Right? My calculator is not moving. Right? Yeah, I asked not moving. The pen is not moving. So here got one tension. Right? You see tension, you can feel the tension. Tension, any other tension. Right? Got one tension there. This tension is a kind of force. Right? But the reaction, you cannot feel it. Tension, you can feel it. Now, when to have no tension? You see, you see properly, Okay. Now, this one, you see, here got tension, Here got tension, Wait, Here, you see, here got tension, right? Here got tension, Now I lower it down, lower it down, lower it down, lower it down, Yeah, still got tension right now, you see. Still got tension. Cikgu tidak tegang This one no tension no feel tension No, nah. Just now here got tension Here got tension Here don't have Why no tension? Why no tension? I ask you one question. Why no tension? Why there is no tension? Yeah, just now got tension. Got tension. But why right now no tension? Right now, no tension. Answer me, why no tension? Tension, this one weight 10 Newton, 10 Newton, This one tension 10 Newton, not moving, tension 10 Newton, right? So I lower it down and put on the table. Why this one tension becomes zero? No tension, no cikgu. Why no tension? Answer me. Why? Why there is no tension? Hello? Why there is no tension? Look at me. Why there is no tension? Why there is no tension? I just want one word. Why there is no tension? Why there is no tension? Hello? Why there is no tension? Come on. I'm waiting for your answer. Because the weight 0 Newton, no? Any other? I give you the answer. Better. But I want you to answer first. Answer me. I got take some other thing to explain to you. I don't know whether it still works or not. A long time not using it. You answer me, why? I wait for your answer. Hello? I wait for your answer. I'm waiting for your answer. I'm waiting for your answer. I think because why there is no tension? Because there is a reaction. Because there is a reaction. Right? If you don't understand, never mind. I do one more for you. You see this one, then you understand better. Now, do you see that is a scale here? What is the reading? 0. I put my Form 5 physics book here. How many? How many? So long time not using it. 0.5 kg, right? 0.5 kg. Now, because now I want to ask you, what is the weight? What is the weight of physics book? What is the weight of the physics book? See? Wait. What is the mass better? What is the mass of my physics book? Your physics book. What is the mass of the physics book? 0.5 kg, right? Now? Right? Now, you see 0.5 0.5 kg Wait. One time. 0.5 kg Now, if I got tension, help me to pull it up. Oh, wait. This one's 0 Okay, I put it down Why this one 0.4 only? Because I pulled it up. I pulled it up, I pulled it up. I need to put further away so that you can see. Never mind. I'll show you again. Yeah. This one, right? The reading will be 0.3 because I pulled it up. Why? Because my normal reaction show me normal reaction you see now here if you understand this one, I'm going to show you this. See, this is the scale. This is my object this is my object, my book, my physics book. So I put it as 0.5 kg or it is 5 Newton, right? I put it as 5 Newton 5 Newton So if I don't do anything, what is the weight? 5 Newton. Then what is the reaction? Answer me. What is the reaction? I don't do anything. I just press it on the scale. What is the reading of the scale? Reading of the scale. What is the reading of the scale? What is the reading of the scale? What's 5 Newton, right? Good 5 Newton senang lah. This one. Siapa tidak pandai. Okay. 5 Newton 5 Newton, right? 0.5 kg, yes. Alright. Now, here I curi tarik sikit. Here, I tarik. I pulled it upward a bit. More compressed to the scale or less compression to the scale. I tarik up a bit with 2 Newton. 2 Newton only. Then tarik up with a thread. So this one will be a tension. More compressed to the scale or less compression to the scale. I pull the book upward a bit. More compressed to the scale or less? Lesser, right? Less compression to the scale, right? The compression to the scale is lesser. Now it show me 3 Newton only. This scale show me 3 Newton. This one not 5 Newton anymore. Why? Because you are not moving. When you are not moving, 3 plus 2 is total weight 5. Because I'm pulling up with 2. Just now, still remember the first. See I need to cut. Okay, now I know it is 0.5 kg, right? Okay, I put it upward, alright, it becomes 0.3 because I'm pulling with 0.2. If I don't, right, it will be, if I don't, it will be 0.5. If I don't, it will be 0.5 because I'm not putting fully 0.5. If I put it upward, it will become lesser. Do you get what I mean? Because I got a force pulling upward. Okay, if you understand this one, it is good. Alright, so now what do we have is, now here, that is a weight, that is a reaction. They will be the same. Reaction is, you can imagine it as, sorry, I forgot. You can imagine it as reaction, normal reaction, you can imagine it as the reading of the scale. Reading of the scale. Alright, So this one is reading on the scale also. Right? You can imagine it as something like you pull it up, right? The weight. If it is not moving, hanging, T is equal to W. Alright. Now, all the thing that I say right now, it is not moving first. Later. Now this one is moving already. So if this trolley it is moving, alright. Now you must see whether it move with acceleration or not. So if it said that it move with constant velocity or not moving, then then the force to the left and right will be the same. Mean the force left and right will be the same. If you watch my video before, right? Last week I did one video for you, right? And we discussed this one also. If I pulled it and then it start to move with constant velocity, mean this is your friction. Constant velocity mean the force that apply and the friction will be the same. Then you move with constant velocity. If we move with constant velocity, then the forward force and the frictional force will be the same. Constant velocity. Constant velocity. But if it move with acceleration, meaning that why it is accelerate? The force is 10 Newton. Oh, 10 Newton. This one probably just 3 Newton only. That's why it got one net force or one resultant force. Then it can accelerate. So that if the object moving with constant velocity, the forward force, I called it as T right now, is equals to frictional force. I use the frictional force as mu. Frictional force easier for me. If you said it accelerate, mean the forward force is more than the frictional force, more than the friction, then it can accelerate. And anyhow, this trolley, it is not going to move up or down. So you can see in this case, no matter what, R is equal to W. No matter what. Because this trolley is not moving up or down. This trolley is not going to move up and down. This trolley is not going to move up and down. So R is equal to W. If you say, oh, W is more, then this trolley down. Okay? You have to understand this concept first. Are you okay? 3 only, still got one more. Right? This one I'll teach you next week. Not today. This one we see it later again. So this one number 4. Alright. Now if I got one aeroplane here, this object it is flying. Not accelerate. If I said it is constant velocity. Constant velocity mean it's not going up already. It is constant height. You want to go to KL, you use your airplane. At certain height, you move with constant velocity and constant height. Right? So constant height mean it is not going upward, it is not going downward. So upward and the downward will be the same. Upward is called lift force. Upward it is called lift. Upward is called lift force. Downward it is called weight. Right? The weight. So upward and downward will be the same. W is equal to L. And T it is called thrust. Thrust, why? Teacher, why you use T not use F? Alright. Thrust comes from the word of T. T is normally engine produced punya force. Right? Normally my privacy let you see guys see cannot lah. Yeah. You guys can see my privacy aduma. Later got people PM me cikgu not cikgu lah. Darling, we dating tonight you guys see IGG later. Yeah, I don't know how to. No lah. You guys can see my privacy but luckily not the kind of person. Okay, yeah, this one is called thrust. This one is called thrust, forward engine got one force, right? Drag, what is drag? Drag is air friction. Air friction is called drag, right? Air friction, this one is air friction. I want to put in here, air friction. Now, normally for airplane, we use drag, right? Now, this one we don't call drag, we call frictional force. We call it as frictional force. We don't call drag. This one forward force, right? If you got one force forward, got engine one. This really maybe inside the battery, got engine one. We call it the forward thrust, or not. You call it as forward force F will be okay lah. No big deal, right? Okay. Now, if this one object is moving with acceleration increasing in altitude, why it is increasing in altitude? Wait, increasing at altitude because of it move upward. So if it is accelerating upward, mean which one is bigger? You want to go up. Actually, if you want to go up, your object here, you want to go up, your upward force must be big. Your T must, not T. This is not tension. You don't have, teacher, why not call T? T normally is tension, right? If you call it as T, mean you got one tali pulling on the aeroplane. That one is toy one, toy. Kapal terbang permainan. The toy one, right? So this one is called weight. Now, if you are I said that this thing, it is going upward, accelerating upward, meaning that which one is bigger? This one is increasing altitude, right? Mean L is bigger than, no, we don't call normal reaction. We don't call it normal. Yes, your concept is correct, but we don't call normal reaction. Normal reaction, you must touching with the surface. Baru ada normal reaction. You see this one touching, you call normal reaction. This you see this one is not touching the something. No normal reaction. You see this one touching the scale. That one is called normal reaction. This one we don't call normal reaction. This one we call lift force, other name. But the concept is the same. So lift is more than W. Lift is more than the W here. If you going upward. If this aeroplane is moving downward, no, I asked in YouTube. If aeroplane, if the wait. Give me 1 minute. First. If the aeroplane moving downward, if the aeroplane moving downward with acceleration, right? So we can say L is more than W, or W is more than L, or answer me. Answer me. L is more than W if this aeroplane is moving downward. I mean, this aeroplane, it is going downward. So, what will it be? Answer. Two more, come on. Yeah. Maybe some of them leave behind. The line not good sometimes. Hmm? Answer me. 5 watts. Two more. Two more watts. If the aeroplane is going downward, right? Meaning that, right? I don't want to wait for you, right? Wait for you every time. Wait for you be very slow. Most of you know, right? But if you W more than W more mean W more. Let's say you said W more. I don't know. I don't know who is getting wrong. That, but then I want to explain because it's any one of you getting wrong. Then I'll explain. This one 10 Newton. This one 2 Newton. Then you pull up with 10. The lift force is 10. 2 Newton pulling down. It will go up. If this kind of question, it will go up. But I said it already said it will go down. Go down mean this force must be stronger so that it will go down. Right? Must be 12 Newton ka 20 Newton, at least more than this value. Then it will go down. If it is the same, this one 10 Newton, go up, lift force is 10 Newton, go down is also 10 Newton, then it will stay not moving, or it will moving with constant velocity at constant height. At what I see just now. Mean it move or not? It move. It move with constant velocity. Huh? And then if this one accelerate forward, which one is bigger? T or G? Of course it is T. If this one moving with constant velocity, mean forward and backward will be the same. Oh, equilibrium. If this one constant velocity, upward and downward will be the same. If this one accelerating upward, lift force is bigger, so that it will go upward. Now, you see, come back to, because you got some of you get wrong, so I will re-explain this one in other way. Right? See. Now, just now, still remember I did one experiment with the scale. This one 5 Newton. That is a weight of 5 Newton. 5 Newton. I said 5 Newton. Because 0.5 kg is 5 Newton. You learn it from 3. Not from 3. We take it as from 4. G is 10. M times G, 0.5 times 10 is 5 Newton. Alright. So if I don't move, this one will be not moving. 5 Newton lah. What is this? This is called reaction. Reaction is 5 Newton. Okay. Now I said, now I don't want to use reaction. I want to put it with 10 Newton. Then what happened? I pull it with 10 Newton. What happened? You answer me. This is very, very logical, simple question. I pull with tali. This one, what is it? My physics book. I tied it with a thread. And then I pulled it up with 10 Newton. You tell me what will happen. You tell me what will happen. What happened? Huh? What happened? Answer me. What will happen? If This one, weight is 5 Newton. The physics book, 5 Newton. And I pull it up with a thread tali with 10 Newton. Then the physics book will how? Not moving, or moving up with constant velocity, or moving up with acceleration, or moving down. Logical question logic question Logical question. Three people vote. Still got. When come to vote, my view getting dropped. Surely leave first. I don't know who are you who is the one who is voting. I don't know. You no need to worry. But you do quiz, you need to be careful. You need to do it properly. I can see who get wrong. Yeah. I tell you last week. Because of some of you get wrong. But most of you, your quiz is doing very well lah. You're doing very well. Then I didn't give extra. I do for from 4 1. From 4 they got some not really sure, so I do for them. 4 what? Come on. Most of you getting correct. 4 words only. Right? But it is okay. You move it with upward with acceleration because of you got a net force that going upward. The net force. Still remember, Cikgu, this one, you see, I ask you into this way, then you remember. Yeah. You see, where will it go? Oh, Cikgu, go to the right. Why go to the right? Why go to the right? Why go to the right? Because, right hand side is stronger. Right hand side is stronger mean you got a net force. You got a resultant force. You got a resultant force. So that you will produce one acceleration. It is going to produce one acceleration. If you said just now, some of you answer, I don't know who, but it is okay. I refresh your mind. Yeah. Last week, if I pull with 5, then you move or not? Move. Then you move with constant velocity. It will not accelerate. Now I pull. This one stronger. Net force going upward, so it will accelerate. So answer is it will accelerate. It is not moving with constant velocity. If I pull it with 5, then this one, I pull it with 5 Newton, then yes, it will. I want to ask you. If I put it with 5, do you think it will move or not? For this case. I pulled it with 5. Do you think it will move or not? Move or not move? Move or not? Yeah, good question. I just feel like I'm bullying you. Alright, so very easy question, right? 5 Newton up the book, the object. Move with constant velocity, right? No. This case no. Why? Why no? Yeah, Janine, your answer is very good, right? I know you what you mean. It will move with constant velocity upward, right? No. Why? Because this one got gravity, keep and pull it down. But this one not saying it will move with constant velocity. Yes, this one will move with constant velocity. Right? That's why. That's why. Yeah? Pull 10 and 10, You were stationary or not moving or moving with constant velocity. Teacher, pull a 10, you move with constant velocity? Yes. If you pull it upward, you will not move with constant velocity. Because your force is not bigger than upward, so the gravity still keep on pulling it down. The not gravity, gravitational force. I mean weight. Keep on pulling it down. So it will not going upward. Do you understand it? So if left light, then it will go with you see this one, it will go to the right with acceleration. This one, it will go to the left with acceleration because left is big. This one impossible. I ask you up or down bigger. So up and down it is the same. Up and down it is the same because I haven't teach you yet. Right? Okay. Now basically you are okay with this one. I hope you are okay with this one lah. Right? These four situation. Right? So this one all I gave you already. This one I don't want to teach you yet. Not yet. Not now. Not now. At least not now. Okay. Now we are going to do some question together. This one next week lah. Okay. Too hard for you. Alright. Now, okay. We do one some examples from here. Now label all the forces in to this diagram. Right? The force acting on the stationary, not moving object. Right? So find the normal reaction. So I want to label, first of all, this is called what force? This is called what force? I need to label. Right? So this is called weight. This one is called reaction. Or if you don't want to use reaction, you can use this word, normal. Don't R over N, cannot. If you want to use N, then N. Me, myself, I like to use R. Right? If you want to use N, your teacher use N, you follow. You follow your teacher. Your teacher want to use normal. N. Alright? Now, which one is bigger? Stationary. Which one is bigger? Which one is bigger? R is equal to W. Why R is equal to W? Because it is not moving. Right? Do you understand it? W formula mg. M 5. G 9.81. 5 times 9.81 equal to 49.05. 49.05. That's all. Are you okay with this? This kind of question will come out in SPM. Yes, can come out in SPM. Can. Okay. I hope you're okay. Now, the second one. Now, label all the forces acting on the stationary object. Right? Salah lah. You see? Not stationary lah. Right. Sorry should be a moving object. This one is moving object. This one should be moving object. Moving object. Label all the force acting on the object. Moving object, not stationary. Stationary means not moving. Still, if I said stationary, where got direction of motion? Salah lah. Right. This is the question that I make on my own. I know where do I salah? Okay. Now here, this is a force. Label it down. What is this force? This is called W. Right? What is this force called? Upward. Stay on the ground. Stay on the ground. What is this force called? This is called reaction or normal or reaction. Now, why this thing moving forward? Why? And then this is rough surface. Rough surface means got friction. So why it is moving forward? Because you got a force here and force here. What is this force called? Rough surface means it is frictional force. And I like to use mu, but your teacher is not using mu, then you better don't. Later your teacher asks you apa itu, then you go to form 6, they will use another formula for friction, mu r. Mu r. So I like to use mu lah, senang, right? But no, now it's labeled with frictional force. If you don't want, you can use you see if you said force frictional force and then you put r also cannot. Why? R is later you thought it is resultant force. That's why very hard to use the symbol here. Kind of hard for us to use the symbol right now. You understand what I'm saying? So we normally don't use symbol for this one. If you want, mu, right? If you don't want, just leave it at frictional force. Or some of the teacher they use this way. Some of the teacher they use it this way. They put it to this way, F, and then like that. Frictional force. Friction force. They can put it into this way also. So this one is, normally we are going to call it as forward thrust, right? Normally we use T lah, or you want to use F, it is okay. Right? Now, I label all the forces in already. 1, 2, 3, 4. Find the normal reaction. Normal. Normal reaction. Normal reaction R is equal to, this one go up or go down? Up or down? Up or down? The trolley on the table, it go up or go down? It go up or go down? What do you think? It is go up or go down? Go up or go down? Up or down? It is not go up, not go down, right? It's move left, right, but not go up and down. So R is always equals to W if it is not go up or not go down, right? W is equals to mg, right? W is equals to mg, and your R gonna be m2g 9.81. No need calculator, I got the answer here. R is equal to 19.62. Do you understand A? You understand A? I hope you are okay. B. Now the trolley pull with 12 Newton forward force, right? Frictional force is 3. Find the acceleration. Now forward 12. Frictional give you 3, right? Fr, net force, is equal to ma. Forward force, net, minus the backward force. That's why it moves forward. The forward force is here. The forward force is here. Must be stronger than this force so that it can move forward. If it is equivalent, it will move with constant velocity. But this question said it will accelerate. I definitely understand this one. The forward force must be more than the frictional force. Must be. Right? So, forward force, the resultant force will be 12 minus 3. It's equal to MA, 2A. 12 minus 3, it is 9. So A gonna be 4.5. Any question from here? This one should be easy for you. This one is the one that we had done last week, right? So last week, which is I don't put it in, right? I teach you because of it is related, right? Now we can see from here, right? We do it fast, huh? Now find the acceleration of the trolley if the frictional force of the rough surface is 5 Newton. Yeah, frictional force, or I label it. Because you go to the 20 Newton this side. So this one will be your frictional force. How much? 5 Newton. They never asked me to label, but I label 5 Newton in for my understanding. It will go to the right because of 20, it is more. It will go to the right because of this 20. 20 bigger than 5. You go to here with the acceleration, right? So how to do it? F resultant force is equal to MA. Resultant force is equal to MA. Resultant force. Up down no need to see already because up down it is the same. R is equal to weight. We are not going to see it. Now we go left right. Right? 20 minus 5 is equal to MA 2A. 15 is equal to 2A. A is equal to 7.5. I hope I'm not too fast. I hope I am not too fast. Now, here, find this question. Find the frictional force of the rough surface. I don't know how much. I don't know. Okay, I name it as M. No lah, F. Friction. I don't know how much. This one I totally don't know how much. But it said that it moving with acceleration, or it move right with the acceleration. How do I know it is moving to the right? How do I know it is moving to the right? Frictional force will not pull the object to the left. No. It will not pull left or right. If the frictional force is too big, then it either not moving. If it is moved, must be your force that causes it to move. Okay. So F is equal to MA. Okay. F. What is F? Big minus small. Big minus small. Bigger force minus smaller force. Bigger force will be 20. I told you frictional force. If frictional force too big, then it will not move. So this one move because the 20 it is bigger. 20 minus friction. This is MA. M3. A don't know. A I know. No, sorry. A it is 2. So 2 times 3 it is 6. 6 you move it to here. Frictional force I move to the right hand side. It is 20 minus 6. Is equal to frictional force. So my frictional force will be equivalent to 20 minus 6, 14 Newton. Can you follow? I hope I am not too fast. I hope you're okay with it. Let me finish 2 more examples. This example I'll do it next week. Today cannot yet. Right. Now, constant velocity. Find the frictional force if the object moves with constant velocity. Why it moves with constant velocity? If you watch my video, you can answer it straight away. But my video it is in Mandarin version. I'm sorry. So, frictional force is? Answer. Frictional force will be? Constant velocity. Constant velocity. Constant velocity. So here got one friction. How much? Constant velocity. Answer? 15 Newton, right? Still remember? Still remember? If you want to calculate, I can calculate for you. If you calculate 1,000 times also, same. So it moves with constant velocity to mean F resultant force, it is MA. Resultant force is 15 minus friction. 15 minus friction. This is A phi. A. How much is A? Constant velocity. A. 0. This one is friction, Alright, no lah, I write it properly. MA, yes. M phi. A 0. Phi times 0. Frictional force, You bring the negative frictional force to here, become positive frictional force. Frictional force, 15 Newton. That's why next time you no need to see. When you see the word of constant velocity, don't care. Left and right will be the same. Constant velocity mean equilibrium. Equilibrium mean left and right. Sama. Same. Okay. Left and right will be the same. Now I'm going to do one more example for you. If 2 kg trolley is pulled with the force F, and then it moves with constant velocity 0.5. Constant velocity, right? Now the force is double. It moves with acceleration. Find the value of F. Tell me what's the frictional force. Okay, we are going to do it together. So, now I label all the force in first. Alright, here we got one friction. Frictional force, Lazy. Frictional force, So here is a frictional force. Here is what? So if I pull with F, it will move with constant velocity. Constant velocity. I don't want to label this one first, right? So if it move with constant velocity mean which one is bigger? If it move with constant velocity, in F is equal to friction. Am I right? The force forward is equal to backward. So it will move with constant velocity. Do you understand this? From the top here. Now, if it pull with force double, mean the force is no more F. Now it is 2F. Right? So 2F, just now you pull with F, secant force, F, then it will move with constant velocity. If you double the force, of course it will accelerate. Right? Accelerate. If it is accelerate mean F forward minus F is no more F. F is called 2F. Why 2F? It said that double of just now punya force. Frictional force how much? Frictional force minus the frictional. Friction still the same. F. Here already know. Friction is F. This is also MA. M 2. A acceleration 2. Yeah. Do you understand? 2F minus F is F. F is equal to 4 Newton. So we know that F is good friction. So friction also equals to 4. Set the value of frictional force 4 Newton. Find the value of force 4 Newton. Any question from here? Any question from here? Now, okay. Let me explain one more time. Not explain one more time now. Alright. I have finished this part already, but not yet. So next week we are going to focus into this one. Next week we got a quiz. Make sure you follow. And now I repeat one more time. My February it is free tuition. Right? You don't need to pay anything. Right? Including the material, no, nothing. Right? So after February there will be charge you tuition fee, but just 50 ringgit only, right? 49.9 lah, right? 50 ringgit lah. So 50 ringgit, and if your friend want to join, you can ask your friend to join also. Must join before. If after, then they will ask me why no more 50, because the promotion will finish before March, right? 28th of February will be finished, right? So ask them to join fast. And then if you ask your friend join, you got an intensive also. Okay? Ask your friend to write your name. Now, any question? Forward this video to your friend also can. I don't mind. Alright. This one is not private tuition. But after March, this kind of tuition will be closed. Right? Mean this one no more public. You want to watch, you must be in my tuition, then you can watch. If no, you cannot watch it. Alright. Any other question before I end the class? Any question before I end the class? Any question before I end the class? If no question, I will end it here. Good night for you. Alright. I see you next week. Next week we baru got quiz. This week, okay. I haven't finished 1.2. Every 1.1, 1.2, 1.3, I'll do one quiz for you. Right? Okay, then good night for you. I'll see you next week. Bye bye. Good night. Good night, everybody. Good night.